All right, let's dive right into the fascinating world of chemistry to uncover a secret you've probably experienced 100 times, but maybe never really thought about. You know that feeling, right? You bite into a slice of lemon and bam, your face just scrunches up. It happens to everyone. But what's really going on there? What is that super sharp, sour taste all about? Well, there it is. The culprit behind that sour face is a whole family of chemical compounds called acids. They are the secret ingredient behind that unmistakable tangy flavor. Okay, so if acids are our culprit, we've got to get a proper ID on them. What exactly is an acid anyway? Time to look at the chemical forensics. When you boil it down, it's really about two key things. First, when you mix an acid with water, it lets go of these tiny little particles called hydrogen ions. That's kind of like its chemical fingerprint. And second, on a special scale we're about to get into, its measurement is always going to be less than 7. So acids have a few telltale signs. There's that sour taste, of course, but please never taste a chemical you don't know to test it. They've got other tricks, too. They can react with metals, they can actually conduct electricity when they're in water, and the really strong ones can be corrosive. In a classic test in any science lab, they turn blue litmus paper red. So, how do we know how strong an acid is? I mean, kind of sour versus really sour isn't exactly scientific. For that, we use something called the pH scale. Think of it as a power meter for chemicals. This scale goes from 0 to 14, and right there in the middle, you have the number 7. That's our baseline, our center point. Pure water, for example, is a perfect 7. It's not an acid, it's not the opposite of an acid, it's just neutral. So anything with a pH value below 7 falls into the acid category. Simple enough, right? That's a huge range, from almost 7 all the way down to 0. But this is where things get a little backwards. Your brain might immediately think that a lower number, like a 1 or a 2, means the acid is weaker or less intense. It seems logical, doesn't it? But with the pH scale, that's not how it works at all. Not a chance. In fact, it's the complete opposite. The lower the pH number goes, the more powerful and concentrated the acid is. So a pH of 1 is way, way stronger than a pH of 6. And 0, that's as acidic as it gets. And that difference really splits acids into two main groups, strong versus weak. The strong ones are the industrial heavy hitters. We're talking a very low pH used in factories and labs, and yeah, they can be pretty dangerous. But the weak assets, those are our everyday assets. They have a higher pH, and we find them all over the place, especially in stuff we eat and drink. Okay, so enough theory. Let's look at the real world. The truth is, you are surrounded by acids right now, whether you realize it or not. Just think about your day. That lemon juice and vinegar are pretty acidic, sure, sitting at a pH of 2 or 3, but check out what's at the very top of the list. The acid in your own stomach has a pH between 1 and 2. That makes it one of the strongest acids here, and it's inside you right now, digesting your last meal. Even things you might not think about, like soda, tomato juice, even rainwater, are all slightly acidic. So, we've identified our chemical culprit, and we've seen the evidence everywhere. But what's the final verdict? Are acids just sour troublemakers, or do they play a much, much bigger role? It's time to ask, why does any of this matter? Well, the truth is, they're absolutely essential. That powerful acid in your stomach is critical for digestion. Acids give foods like yogurt and sourdough their fantastic flavor. They're the key ingredient in car batteries, they make lots of cleaning products work so well, and they are fundamental to just about a million science experiments. You could really say it all boils down to this. From our own bodies to the technology we use every day, acids are a fundamental part of the chemical engine that makes the world go round. Of course, with all that power comes a serious need for respect. It is so important to remember that while the weak acids in our food are totally fine, the strong, low pH acids are a whole different ballgame. They can be incredibly corrosive, which is exactly why you always see scientists wearing goggles, gloves, and lab coats. Safety always comes first. So, to wrap up this investigation, I'll leave you with one last question to chew on. Now that you know how the pH scale works, if lemon juice has a pH of 2 and vinegar has a pH of 3, which one is actually the stronger acid? The answer really shows you just how much cool chemistry is happening right in your own kitchen. Thanks for joining.